Today we are talking about if-then statements. We talked about this a little bit on Monday. I always use the example at my other school, if you poke the bear, then you die. We're going to start off with, if you call the police, then you have had an emergency. There are two pieces in an if-then statement. One of them is what happens after the if, and the other one is what happens after the then. Awesome, you are so smart. Okay, what we call what happens after the if is called the hypothesis. So anything after the if, this is your hypothesis. What do you think you call the next piece?
Result.
It's the conclusion. Anytime you have an if-then statement, all the junk after the if, hypothesis, all the stuff after the then, conclusion. Believe it or not, math and science, we do kind of connect at some point. You can take most statements, like if they give you a statement in the book, you can turn most statements into an if-then statement. Like, somebody can make the statement, babies are illogical. You can turn that into an if-then statement. Anybody want to try it? If you are a baby, then you are illogical. Why do you think somebody would say that?
Because babies aren't smart.
Right, babies can't articulate, so you can't really tell whether or not something works that way or not. I have no idea where this statement came from in the book, but this is an example they give. Nobody is despised who can manage a crocodile. How can you turn that one into an if-then statement?
Because the crocodile eats people.
If you can manage a crocodile, then
You're not despised.
you are not despised. And they love these words in here. Here's the next statement they give as an example. Illogical persons are despised.
If you are a logical person, then you are despised.
Or if a person is not logical, then the person is despised. That's what they're called. So we also have ways of representing this, and I know this makes no sense, but the way that they do an if-then statement is we talk about something, the hypothesis and the conclusion, but they actually kind of have symbols to represent that, and they're letters, which it does not make any sense why they choose these, but it's the way that it works. P results, I think it's Q, let me double check that. Yeah. That represents if P, then Q. This is the way we represent them using symbols. Again, don't ask me why, it's just the way that they do it. What does the word converse mean? Shoes, nice. Kind of.
Same. With, same, something.
Like whenever they're having a conversation.
Kind of like that, yeah.
Within each other.
Yes, so an if-then statement is a P, then Q. A converse is we're actually going to swap the two numbers, Q, then P. So we're actually going to take, so this is hypothesis, if-then statements. The next thing we're going to talk about is converse. V-E-R-S-E, Q, then P. So, if you have a P then Q, the converse is we're going to switch the Q and the P. That's all we're doing is we're swapping it. So whatever the hypothesis is, we're going to turn that into the conclusion. We're going to take the conclusion and turn it into the... Yes. So let's use my silly one. If you poke the bear... then you die. So let's first talk about the hypothesis and the conclusion. What is the hypothesis? You poke the bear. What is the conclusion? Poke the bear, death. Okay, so now we're going to do the converse, which means the if and the then get to stay, but all the other junk moves. So the converse, which would be this up here, this is the P, then the Q. Now we're going to do the Q to the P. I know, so confusing, isn't it? So now we're going to flip what happens. If Now move the converse. If you die,
Then you over to the bear.
yes. The converse means we are just taking the hypothesis and the conclusion and we're flipping them places. That's all we're doing. Is it possible that whenever we do a converse that the statement could be true?
Yes.
Is it possible that it could be false? Absolutely. There are times that they will ask you if a converse is true or false. Let's see if they have. Oh man, that's so aggressive real fast. Okay, so let's look at one particular example that pertains to geometry. If two angles are adjacent, so picture that in your mind. What does adjacent mean? They're next to each other. Then they have a common side. So now what would be the converse be?
If they have a common side, then they're adjacent.
Yes. Is that a true statement?
Yeah.
Is it possible that somebody could share a common side and not be adjacent? Yes. So then they may ask you to draw a picture showing where that would be a false statement. Did he just groan like, no, don't want to? Yeah, it is very much possible. If a statement, I'm telling you, this book is so wordy. There are times I really just don't like it. The denial of a statement is called a negation, meaning it negates it. It makes it untrue. Now, I want you to think back to Algebra 1 and Algebra 2. What does the word inverse mean? The opposite of. So instead of just writing something differently, we're actually going to turn it into a negation, meaning turning it into a negative. So if somebody says something that's positive, you're going to turn it into a
Negative.
yeah. So I'll tell you what that means. Let me see if they have a good example. So if you have an original thought, which is, what was our very first one that I made you write down?
If you call the police, then you're in an emergency.
Yes. If you call the popo. So now we're going to go with inverse. So this means I'm going to negate the first and negate the second one. So if you didn't call the police, then you? Yes. So would that be true? Partially. Can you have an emergency and not call the police?
You're gonna get in trouble for it.
Is that how they spell Popo? That's a
It's the
weird.
least of our words.
That's a weird word.
The popo.
It's a nickname for the slang.
They are going to take all of this information that you're learning about the words and they are going to apply it to geometric theories and thoughts. Man, there is so much in this section that's hard. This is where I think that you really have to be a careful reader in this class. There is a lot that they are going to do to basically double talk, and you're going to have to read through the double talk to figure out what they really want you to do. We've talked about all kinds of different forms, and now we've talked about the inverse. So you have a regular if-then, you have a converse, you have an inverse, and one more thing that you have is something called a contrapositive. Y'all ready for all this business?
Double positive?
The contrapositive is switch both of them and turn both of them negative. Isn't that gross?
What is both?
So you're going to switch your P and your Q and turn them both negative. So you're not just negating both, you're switching them and turning them both negative. So it would look like your normal hypothesis conclusion relationship looks like this. Contrapositive means you're going to switch both of them and you're going to turn them both negative. So let's think about if you call the police, then you had an emergency. So switch them. If you didn't have an emergency, then you didn't call the
Police.
both of them negative, both of them switched. Isn't this gross? Welcome to geometry. It's lots and lots and lots of words that you've got to depict through. And on top of that, you have a lot of postulates to write down today. Whew. A whole lot. Okay, now that we have gone really, really difficult, let's make it a little bit easier by charting it. Does that sound better?
No, not really.
Okay, if then, P then Q. So if you had to say converse, what are your letters?
QP.
Q then P. What was the next one? Inverse? What was inverse? Come on.
Q, negative P.
Negative P to negative Q. And what was contrapositive?
Negative Q.
Negative Q to negative P. What does P stand for? Hypothesis. What does Q stand for? So it might be a little bit more helpful to write it like this. And if you have to draw yourself something over here, P is hypothesis. And Q is conclusion. If you want to make it even easier for yourself, the hypothesis comes after the yes, so this is after the if. And this one is after the yeah. If two angles form a straight line, then they are worth 180 degrees. This is how it's going to start to play out in geometry. If two angles equal 180 degrees, then they form a straight line. Which one is that? Converse. Is it necessarily true? Not necessarily true. Can you have two angles that are next to each other but don't touch that still make up 180 degrees? Yeah, still doesn't mean they're a linear pair, right? So let's think of that in an inverse. What did I say our first one was? If they form a line. All right, so here was your original. Our converse was if they're worth 180 degrees, then they form a line. Now, inverse means let's negate both of them. If they do not form a line, then they are not worth 180 degrees. Now, contrapositive. Who wants to try that one?
If they're not 180 degrees, then they are not a line.
Perfect. You just have to know how to move things around. So as long as you know how to label them, you can know how to flip-flop them around. And if you're going to inverse anything, you just throw a negative somewhere in there. Make it negative. So, are you ready for postulate 1, 2, 3, 4, 5, and 6?
What are postulates?
Yes, I'll leave that up for a minute. Brady just asked that a minute ago. Postulate is basically a truth that can be explained through evidence over time. So basically, it's like a factual statement on why something does what it does.
Can you spell an explanation?
Well, in the book, you have to know that they're called postulate.
Oh,
And as we get through this particular chapter, they will ask you for which postulate explains why something happened.
That sounds nasty.
It is nasty, not gonna lie. Which is why in this class, your notes are critical to what you are doing.
When we were in Algebra 2 and we had to tell whether something was quotient theory or multiplicative, Z zero.
Yes, additive identity, multiplicative identity.
No, they were all about power things.
It
The
is-
power rule.
Your brain is
Wait,
Uh,
what was the power rule?
We were driving to pick Brady up last night, and guess who I saw? They were on Midway Road heading towards Versailles.
Jennings.
Really?
Yeah, and I was, he has a very distinct car, and he's a very distinct looking human, and I went, oh my gosh, I know who that is. It's like,
What car does he drive?
scary. A little, teeny tiny little sedan that's like this weird green color. Alright, so, I'm just gonna write postulate, and I'm gonna assume that you know that each one of these is a postulate. Does that make sense? So we'll try to make them as condensed as we can. So I will do my best to condense them and put them into my own words versus the confusing words that are in a book. If you have 2 points, what can you form?
A vertex.
I like the way she's thinking, but not yet. Through any 2 points, there is one line. So that's what postulate 1 says. Through any 2 points, there exactly one line. Only one line, because 2 points make up a line. I know that this is a postulate, but in my analytical brain, this next one, I'm left thinking like, hey, wait a minute. I could think of a converse for this, but that's me. Through any 3 points not on the same line, there is exactly one plane. I think back to that one question on the test where you had 3 points. One of them was outside the plane. But this says, for any 3 points that are not on the same line, one plane. Oops. And again, that one does make me think. Because we've seen times where there has been. Postulate 2.3 sounds a whole lot like postulate 2.1. A line contains at least 2.
Points.
Yep. Can it contain more? Yeah. Especially if it goes on and on and on forever, you could have an infinite number of points, but it has to have at least 2. Now, here's another one. A plane contains at least 3 not on the same line. It's like saying the exact same thing again, but backwards, right? A plane. Postulate 2.5 blows my brain a little bit. If 2 points lie in a plane, then the entire line containing those 2 points lies in that plane.
She tried it too.
Guess whose door got fixed? It's
So say that
delightful.
again.
You don't even go here.
I know. I finished my test.
For who?
She got
Douglas.
Can you say that again?
If 2 points lie in a plane, then the entire line containing those 2 points lies in that plane.
Wait, but it
Okay.
can intersect with the plane.
They're in
So
it.
it's just saying,
But what if
the
they're-
points lie in the plane, then there's gonna be a line that lies in the plane.
Pretty much.
Okay.
If 2 points lie in a plane.
How's that for two?
Again, my brain works a little bit differently on that one because in my brain I'm thinking, well, they're 2 points, but we never said that there was a line that connected them. But the book is saying that it does.
Maybe it's supposed to be understood. We just
Yeah.
don't understand this.
Okay, now if 2 planes intersect, what is their intersection? It's not just at a point, but it's at a, yeah. If 2 planes intersect, they intersect at a line. Remember the weird picture you had to draw on the last test that basically looked like the 2 sheets of paper like intersected like weirdly?
Yeah.
That's kind of it.
I drew sand type.
I'm such a visual person that for me, these postulates I think are harder for me because I want to be able to see them. I don't necessarily want to be able to have an example word-wise, I want to be able to see it. So those are your postulates. Now, a majority of the work that you're going to be working on is about the if-then statement. And again, that little chart that we made will be helpful. What? One of them is a quote from 1975. I've never heard this before, but if you can sell green toothpaste in this country, you can sell opera.
Is there a possibility for the if statements for one to be negative and one to be positive?
Mm-hmm.
What's that?
One negative and one positive. If you
No, like
don't
it's-
brush your teeth, then you get to go to the dentist.
Okay, that's positive, sure.
Yeah, so that's a negative in the beginning and a positive in the end. You're gonna get a reward. The reward's not a fun reward, but you're still getting a reward. You get to brush your teeth a whole lot. Okay, so if you will turn in your book to page 80 and 81.